Lesson 10.7 is using word problems. So we're going to use some specific formulas that can be modeled by exponential growth or decay. In class, I'll talk a little bit more about what compound interest is and what half-life is, but for the purposes of this video, I'm just going to talk about the variables you need to use the formulas and do some examples. So for this first formula that you see here, A equals P, 1 plus R over N to the NT. Just quickly to define the variables for you. Let's see, where do I want to start? This P value is the initial amount. And A is the ending amount. We also have R, N, and T. R stands for the rate. You do have to make sure to always convert a percent to a decimal. N is referring to the number of times the number of times we're compounded in a year. I'll just write number compounded per year. And then finally, what am I skipping? T is time. Again, I'll talk more about what interest is in class, and it'll make more sense when you see an example. But for this video, those are the basics that you need. When we're talking about half-life, which is a exponential decay, pretty similar. This here is our initial amount, and the N is our ending amount. So that's pretty easy to memorize because it's very similar to the compound interest. T still means time, so that's the same. And then the new one is this variable H. H is referring to the half-life. Okay, let's see some examples. Example 1, $1,000 is invested at 7.2% interest compounded quarterly. How much will you have, A, after 2 years, and B, after 10 years? Okay, so we're using our compound interest formula here. Let's figure out what we're solving for and all of the variables that we need to plug in for. So let's identify these. So it says $1,000 is what we initially invest. So $1,000 is that P value, what you initially put in. It says that's invested at 7.2%, so that is our rate. But remembering that our rate needs to always be converted to a decimal, so it's 0.072. This interest is compounded quarterly. That's going to give us our N value. Remember that N represents the number of times it's compounded in a year. So quarterly means 4 times a year. So that's an N of 4. And the question is, how much money will you have? So that's the ending amount. So the question is, we're trying to find A. And then we have 2 different problems, each where we were given a T, a time. So let's first do part A. So we're trying to find A. We know P is 1,000. 1 plus our rate is 0.072 over an N of 4 raised to the N times T. So our N is 4, we said, and our T is 2, so N times T is 8. And that's it. We just want to put that in our calculator. We'll round it to 2 decimal places since we're talking about money. And you get $1,153.41. Same thing idea with the second part, except the only difference here is you're changing the time. So after 10 years, so what's going to change about this problem is we're going to take 4 and multiply it by the T, which is 10, so our exponent's going to be 40. So after those 10 years, you'll have $2,041.32. Example 2, the value of a new $35,000 sailboat decreases 10% per year. Find its value after 3 years. Okay, so let's identify our variables first. So we start out, our initial cost of the sailboat or value of the sailboat is $35,000. That's our P. I see a percent here, that's our rate. First of all, it needs to be converted into a decimal. So that's going to be 0.1. But also notice it says the rate is decreasing. If that's the case, we need to have a negative rate. So R is negative 0.1 per year. So it's decreasing by this rate every year, once a year. So that's our N, and it's just 1. And then the question is to find its value again. So that's our capital A after 3 years, T. So let's solve. So we have A equals 35,000. 1 plus negative 0.1 over 1 to the NT. Now we have our N of 1 and our T of 3, so our exponent's just going to be 3. So after 3 years, our sailboat's only going to be worth about $25,515. Example 3. How long will it take an investment to triple at 6% monthly? Okay, so notice that we're solving for a different variable here. It says how long. So we're solving for some sort of time. Okay, so we don't know what our initial investment is. They're just saying it's an investment. So maybe we want to call that X. When we don't know something, let's just define that as X. The goal is for it to triple. Okay, so we'll hold on to that. 6%, we know that's our rate. So it's increasing, it's tripling, so it's positive. Sorry, that was ugly. Let me erase that. Oh, just scratch it out. So that's 0.06. And then we're compounding monthly, so N is equal to 12. Because it's compounding per year. So if it's monthly, 12 times per year, because there's 12 months in a year. Okay, so let's write down our formula. We have A equals P 1 plus R over N to the NT. Throw in some of that stuff we know. We have our rate is 0.06, N is 12. We said N is 12, so that's 12 up here. We're not going to have anything to plug in for T because that's something that we're solving for. Now the question is how to represent A, the ending amount, and P, the initial amount. Well, we don't know what the initial amount is. We just called that X. So if we call that X and say we don't know it, I do have a way to represent what A is because A is triple that. So triple X is 3X. And that's how we're going to handle not knowing A or P. Because if you notice then, if I just divide both sides of the equations by X, it doesn't matter that I don't know what the investment is. I'm really just going to be looking at the equation. 3 equals 1 plus 0.06 over 12 to the 12t. Okay, let me simplify inside parentheses there real quick just to make it look a little neater. Now here's the question, how do you solve for t when it's up in the exponent? What you need to notice is that this is in the form a to the c equals b. It's in the opposite order here because it's written, you know, b on the left-hand side, but I could flip it around and we have a to the c equals b. We can solve this using logs because remember, we can convert this to log base a of b is c. So let's do that. This is going to be log base 1.005 of 3 equals 12t. And then finally, to get t by itself, we would just divide both sides of the equation by 12. Now remember from one of our previous lessons, you have the option, you can either enter this this part, this numerator, into your equation with the log base button, or you could do the change of base formula. So I'm going to write it with the change of base formula. So log base 1.005 of 3 is the same as log of 3 over log of 1.005, where that's just the log button on the face of your calculator. And then not forgetting our 12 there in the denominator. So typing this into our calculator will give us an approximation, which is going to be 18.4 years. Example 4, the half-life of a substance is 3.5 days. How much of a 100-gram sample will be left after 2 weeks? Again, in class, we'll talk a little bit more about what half-life is, but for the purpose of this video, I'm just going to run through this example with you. So first we need to identify our variables. It says the half-life is 3.5 days. That's our H, half-life. It says how much of a 100-gram sample. So we're starting out with 100 grams. That's our initial amount. The question is how much will be left. So that's our ending amount. So we're looking for N after 2 weeks. This is our time. Now, important thing to notice here is that you have your half-life in days and your T in weeks. You have to make these units match. So I'm going to go ahead and put it in days and just rewrite 2 weeks as 14 days. Okay, let's plug everything in. So we have N equals our initial amount of 100, 1/2. T is 14, H is 3.5. And that's it. It's just entering it into your calculator now. This is 6.25. Our original sample was in grams, so we're going to still end up with grams. Okay, that's lesson 10.7. So that homework's on Schoology for you to try.